So I'm a little annoyed at my computer right now. It said that my USB connected mic didn't work and it wouldn't let me switch up a mic, so I had to separate these two recordings. Oh well, such is life. So we were previously talking about what sort of things affect liver metabolism. So this is going to be a really important part of biotransformation of drugs. Um, so, one of the things that we find is that the more that you take a drug, the better your body becomes at breaking it down. So, generally, repeatedly taking a drug over time can increase the enzymes that would be involved in breaking that drug down. Ultimately, what this means is that the more often that you take a drug, the more enzymes are going to break that drug down and the less of an effect you are going to feel. And this is going to come into play when we talk about things like drug tolerance. Now, there are some types of drugs that are basically designed to inhibit those enzymes. And so, whereas increasing enzymes would be enzyme induction, drugs that inhibit enzymes, basically, they are going to be involved in enzyme inhibition. And there are some individual differences in things like liver metabolism. When we talk about alcohol enzymes that break down alcohol, there are some genetic factors that differ by ethnicity. The nutrition that you have may also play a role. We know that aging can affect liver metabolism. And another thing that also can affect liver metabolism, again, is something like sex. Okay, so we are finished with biotransformation, and then we finish up with excretion or elimination. Now, the most common way to eliminate a drug is going to be through urine. As I kind of mentioned, it's not only urine that this drug will be released, it can also be excreted through the feces, the sweat, the saliva, and breath. But ultimately, this is going to depend on the type of drug. Now, going back to those first order kinetics, that is basically related to both the biotransformation rate and the elimination rate. And what we do find is that if drugs are not ionized in that biotransformation process, or if they are not broken down, they may be reabsorbed back into the body. So now let's talk about drug receptor interactions. So this is where we move from pharmacokinetics, where drugs are absorbed and distributed throughout the body, and we start talking about pharmacodynamics instead. So now we're actually talking about the interactions of the drug with target tissues. Now, when we talk about receptors, these are protein molecules that are going to selectively bind to ligands. Now, what kind of ligands are we talking about here? Well, specifically, we are talking about neurotransmitters, we're talking about hormones, and we're talking about drugs. Now, what are some common characteristics of receptors? So generally, it's going to target a very specific molecular shape. So different types of neurotransmitters and drugs that mimic those neurotransmitters will have a very specific shape that will only bind to certain types of receptors. Binding is going to be temporary in nature. It is not meant to be a permanent process. Additionally, receptors will change in response to environment. Much like we saw with liver enzymes, if you take too much of a drug, these receptors may cut their numbers so that drugs don't have anything to bind to. So depending on the environment, receptors may increase or decrease their numbers. And generally, what we're going to find is that differences in chemical structure and receptor structure lead to different types of effects. So really quick, I want to talk about a distinction between caffeine versus theophylline, which is another substance similar in chemical structure to caffeine, but it's more present in tea. So here I managed to pull up an image of the chemical structure of caffeine, which is right here. Here is theophylline, which is primarily found in tea, and then theobromine, which is found more often in chocolate. Now, one of the things that we're going to find is that caffeine and theophylline, because they have a very similar chemical structure, they have very similar effects. Theophylline, like caffeine, will also give you energy. However, the differences in chemical structure mean that theophylline has different types of chemical effects compared to caffeine. For example, theophylline actually has more of a diuretic effect, which means you are going to want to urinate more often than you would if you had something like plain caffeine. So that's kind of what I mean by the chemical structures having different types of effects. And drugs can have a variety of different effects on neurotransmission. So you're looking at figure 4.8 in your book. So here we have a couple of different examples. So here we have tyrosine, that precursor for levodopa, and then dopamine. So a drug can be a precursor for a neurotransmitter. It can increase supply. Drugs like tetrabenazine can block transporters for vesicles, which means that the neurotransmitter never gets released. Antipsychotics like haloperidol can block receptors so that the neurotransmitter cannot bind. Entacapone basically blocks this enzyme from breaking down dopamine, so it allows dopamine to stay in the synapse longer. Cocaine can block reuptake, so basically allowing dopamine to stay in the system longer. Moclobemide basically prevents monoamine oxidase from breaking down dopamine. So again, allowing dopamine to stay present in the synapse for a longer period of time. So drugs can act in a variety of different ways that can either enhance the effect of a neurotransmitter or it can inhibit the effect of a neurotransmitter. So drugs that ultimately enhance the effect of a neurotransmitter are referred to as agonists. Drugs that inhibit the neurotransmitter are antagonists. And we can talk about different types of antagonists. So we have what are called competitive and non-competitive antagonists. So there are some drugs that compete with agonists to reduce their effects. And these are what are known as competitive antagonists. They make use of the same receptor sites and they basically block agonists from binding to those sites. So for example, naloxone, which is sold under the trade name Narcan, is an opioid that is designed to counteract overdose, particularly respiratory depression that happens with overdosing on opioids. And it does this by binding to opioid receptors and effectively blocking opioids from binding to those sites. Now, we can also have non-competitive antagonists. Non-competitive antagonists typically are not going to use the same sort of receptor mechanisms. They are antagonists, but they're not going to effectively block drugs from accessing or neurotransmitters from accessing receptor sites. So how does repeated use ultimately affect our biology and our behavior? So I've kind of mentioned that the more often that you take a drug, the better your liver becomes at metabolizing drugs and the fewer receptors that will bind to that drug. So drug tolerance is basically a reduced reversible response to a drug after repeated use. What we find is that you'll often need to take a higher dosage of a drug to obtain the similar effect, a similar effect to prior use. And this is ultimately going to occur through three different mechanisms. So I've already mentioned that pharmacokinetically, the liver is going to break down the drug into its metabolites much faster because of things like enzyme induction. Additionally, we're going to have a pharmacodynamic response of down-regulating and cutting the number of receptors that will respond to that drug. The third mechanism is a basic learning and conditioning process. So one of the things that we will find is that repeated drug use occasionally, the more that we take a drug, the more we become used to its effect. We habituate to it, and that will be tolerance. However, we do know that repeated drug use can occasionally sensitize us to a drug. And so basically what we find is that we can get enhancement of effects after repeated use. Researchers have sometimes found that when you repeatedly administer cocaine to animals, their twitchiness, what we would call stereotypies, these kind of limb movements that are very twitchy and very rapid, actually becomes worse with repeated administration. So drugs can create tolerance for some effects and sensitization for other effects. So folks, that's all I had for talking about pharmacodynamics and pharmacokinetics. I will see you next time when we talk about drug abuse and drug addiction.